So in the last class, we had talked about the statistics, and I had asked you people to kindly go through the notes and specifically for entropy and information gain. So definitely entropy and information gain are not mentioned in your syllabus, but undoubtedly in data science, entropy and information gain actually is very much required. So still I had mentioned over there what is entropy and what is information gain, how we have to calculate it, and there is one example and बहुत easily समझ में आ जाएगा. उसके बाद confusion matrix है जो कि मैंने कल की क्लास में भी बोला था that confusion matrix मैं यहाँ पर cover नहीं करूंगी when I'll start with the machine learning algorithm and specifically when we'll be going for the practical at that particular moment of time I'll tell you what exactly the confusion matrix is. So what information we get from confusion matrix? So just understand that the confusion matrix is the implementation of statistics. So हम जो भी कुछ कर रहे हैं, जो भी हमारे पास information आएगी, वो confusion matrix के अंदर जो आ रही है, वो statistics का concept लेकर के निकाला जा रहा है. Fine class. So I guess how many students are there? 22. I'll wait for another 1 minute and then I'll start with the probability. Till now anyone is having any query? किसी ने अभी तक अपना project नहीं final किया? Yes class. It's almost अब तो जुलाई आने वाला है तुम्हारा, तो तुम में से किसी ने कोई प्रोजेक्ट फाइनल नहीं किया है? You people have to submit your projects.
मैम ठीक से समझ नहीं आ रहा कि क्या करना है प्रोजेक्ट में.
मैं तुम लोगों को अपनी गूगल स्प्रेडशीट दिखाती रहती हूँ, तुम लोगों को दिखता नहीं है, समझ में नहीं आता कि एग्जैक्टली क्या करना है. आस्क मी देन अक्षता, व्हाट इज द प्रॉब्लम?
मैम
यस
डेटा
अक्षता.
सेट ले लेंगे, टॉपिक समझ में आ गया, वो तो समझ में आ गया, लेकिन उतने अच्छे से कोडिंग नहीं आती है जैसे आप उसको विजुअलाइज कर लेती हैं. चार्ट्स वगैरह नहीं बनाने आते हैं.
बेटा आएगा आएगा. सी वेरी क्लास, just let me know one thing. Did we start with any kind of machine learning practical till now?
नो मैम.
नो. फाइन. एंड कितने हम लोग अभी तक कौन से प्रैक्टिकल करते आ रहे हैं?
अभी तो लूप और मतलब बेसिक पाइथन के.
So we are just actually learning only Python. We didn't start with the actual concept of data science. ठीक है? So the problem with our system, I mean जो हमारे को सिलेबस मिला हुआ है, अगर तुम उसको ध्यान से देखोगे तो last one unit, in fact second last unit is only for machine learning. सबने अपना सिलेबस देखा है?
यस मैम.
तो होना क्या चाहिए that you should have a basic knowledge of Python and we have to simply start with the implementation of the machine learning algorithm. Concept ये होना चाहिए. But the problem is तुम अगर अपना सिलेबस देखोगे तो 75% course is for the Python and remaining 25% is being distributed for the machine learning. और होना क्या चाहिए था इसका उल्टा. So the problem is right now you people are going only for the Python. और अगर तुम अपने Python के I mean अपने machine learning data science के practicals देखोगे तो उसमें जो list डाल रखी है, you people will think of that they are machine learning algorithms. Yes, they are machine learning algorithms. The practicals are related to machine learning algorithms, but the problem is they are not just machine learning. Only first two practicals are machine learning, rest other are deep learning. और तुम्हारे कोर्स में deep learning है?
नो मैम.
लास्ट में एक लाइन लिखी हुई है overview of deep learning. So deep learning is basically neural network. Are we going to study about exactly? Are we going to study about neural network? You think so? No, we are not. Even that's the only reason why I am giving you the notes for information gain or entropy or any other thing जो कि मैं अब आने वाले टाइम में देने वाली हूँ. Why? Because they are actual concept of data science. मेरे लिए बहुत आसान है, मैं कह सकती हूँ प्रोबेबिलिटी तुम्हें आती है, मैं सीधा बायस थ्योरम कराती हूँ. लॉजिक नहीं है, क्योंकि प्रोबेबिलिटी का जो बेसिक जिस्ट है या स्टैट्स का जो बेसिक कंसेप्ट है जो हम एक्चुअली में इंप्लीमेंट करने जा रहे हैं या जो एक्चुअल कंसेप्ट है जो डेटा साइंस के लिए रिक्वायर्ड है, इसलिए कराना पड़ रहा है. द ओनली प्रॉब्लम इज दैट योर सिलेबस इज नॉट वेल डिजाइन्ड. फाइन. सो माय सजेशन अगेन, डोंट वेट कि तुम्हारा पहले मशीन लर्निंग एल्गोरिथम शुरू हो जाए. What I'll do in the next practical class, I'll start working for the machine learning algorithm. Can I do that?
यस मैम.
So fine. I'll talk to Monica ma'am कि उस दिन मैं practical कराती हूँ and I'll actually show you कि exactly क्या क्या चीजें तुम्हें जरूरी है करने के लिए. Means तुम्हें डेटा सेट कैसे लोड करना है, डेटा सेट के बाद तुम्हें क्या वैल्यूज लेकर के आनी है, कौन कौन सी कमांड्स पर काम करना है, वो मैं तुम्हें बता सकती हूँ. ठीक है? बट डेफिनेटली उससे पहले तुम्हारा नमपाई, मैथप्लॉटलिब, पांडास ये सब तुम्हें नहीं आता, क्योंकि जब तक वो मोनिका मैम नहीं शुरू कराएंगी तब तक हो नहीं पाएगा. बट डोंट वेट फॉर मोनिका मैम की पहले वो करा दे, बिकॉज दैट इज वेरी इजी, बिकॉज इट इज अ लाइब्रेरी फंक्शन, यू हैव टू कॉल इट. गूगल पे भी डालोगे ना टू प्लॉट अ बार चार्ट, वो उसका कोड दिखा देता है, या उसका उसका कॉल करने का फंक्शन बता देता है कैसे बनाना है. तो तुम्हें अपने आप पता चल जाएगा. सो तुम्हें पूरी हार्ड कोडिंग नहीं करनी है. यू जस्ट हैव टू कॉल वन फंक्शन. इट इज सिंपली प्लॉट बार, एंड अंदर तुम्हें पैरामीटर्स पास ऑन करना है कि किन के बीच में तुम्हें बार चार्ट बनाना है. गेटिंग माई पॉइंट क्लास? सो दैट्स द ओनली रीजन आई यूज टू शेयर माई गूगल कोलैब विद यू पीपल, कि हाँ देख साथ साथ दिखाती जाऊं, ताकि तुम्हें exactly पता रहे कि हमें करना क्या है. Shall I start with this probability? So on
Yes, ma'am.
Tuesday, I'll solve your problem on Tuesday. Fine. So let's start with probability. So what is probability? हाँ बेटा.
Ma'am, we didn't get the notes.
बेटा किसको नहीं मिला? गूगल क्लासरूम पे
मैम
मैंने
वो
शेयर किया.
क्लासरूम पे नहीं था.
मैम आपने रिकॉर्डिंग शेयर किया है.
नहीं बेटा, मैंने एक्चुअली वो भी शेयर किया हुआ है, क्योंकि मैंने जब ये बनाया है उससे पहले ही मैंने आई थिंक 2 या 3 पीडीएफ शेयर किया है. लेट मी चेक. अगर नहीं किया होगा.
मैम वो स्टार्ट वाले में तो 2 ही.
स्टार्टिंग के
अच्छा.
नोट्स
ओके फाइन. I'll share this one also. Okay, I'll share this one. Fine. अभी क्लास के बाद ही शेयर कर दूंगी. ठीक है. Okay, who will tell me what is probability? Let's talk about probability. What is probability? This word.
Probability means chances of any event to occur.
Chances of any event to occur. Okay, so on Tuesday Sonia ma'am will go for the machine learning algorithm practical, or she will tell us something about the matplotlib or pandas or numpy, or how to load the data set. What is the chance of doing that event? You tell me. Can I predict that? How many of you say that yes, 100% Sonia ma'am will take that particular class?
half and half.
No,
Half?
ma'am, it's not 100%.
Exactly. So the first thing, the probability has to be between 0 and 1. So chances of occurring a complete event with 100% probability cannot occur. Chances of that particular event with saying ki it will not at all occur is equal to 0. It cannot happen. It has to be in between 0 and 1. So it is like yes, 70% शायद मैम ले ले, maybe 30% are chances she might not come, और या मोनिका मैम कहीं नहीं वो वाले practicals नहीं कराने, पहले ये वाले कराने हैं. It could be any of the circumstances. So chances of getting an event to occur is basically the probability. And why we are going to learn about probability? Because it helps us in doing something called as prediction. हमें क्या काम करना होता है machine learning algorithm से? Prediction कराना जरूरी है. So उसके लिए हमारे को probability का पता होना बहुत जरूरी है. ठीक है? So first thing, the definition is okay. Now, what is the relationship between statistics and probability? So it is a very clear we used to say it is a common misconception. What misconception is, I don't know. But can anyone let me know what is the difference between these two? Despite the fact they are related. I hope last class में किसी ने मुझे बोला था, ma'am, this is nothing but expectation. Yes or no?
Yes,
E of
ma'am.
x is expectation. If it is expectation, तो probability is also the expectation of an outcome. होगा या नहीं होगा, that is a different thing. But it is an expectation of outcome. So are they related? Yes, they are related.
Ma'am, probability works on the defined data set, whereas statistics can be a part of population sample study of
So basic,
sample.
बिल्कुल. So we can simply say that statistics actually define the data set. कि exactly data set होना कैसा चाहिए. And probability is being used on that data. ठीक है. जिसको मेरे को प्रिडिक्ट कराना है वो डेटा पहले मेरे पास होना तो चाहिए. First I should do the analysis on that data set, exactly what we want to fetch the information, and prediction तो उसी के बाद होगी. So basically what is the probability, and they are related because हम statistical analysis उस data set पे करते हैं. So the designing of the particular data set is being done by the statistics, and जो mathematical formalities करनी है उस data set पर वो probability करता है. So they are interconnected. They are not like कि नहीं होगा. I mean कि probability is a different set of mathematics and stats is a different set of mathematics. Yes, they are, but they are interrelated. So if there is a probability, definitely statistics is there. If there is a statistics, so definitely probability will occur. So now we get to know कि what is the probability. हमें ये clear हो गया. So just understand स्टैटिस्टिक्स पहले क्यों पढ़ा हम लोगों ने? क्योंकि हमें डेटा सेट के फीचर्स को डिफाइन करना था, हमें पता करना था कि क्या पीस ऑफ इंफॉर्मेशन हमें डेटा सेट से मिल सकती है। तो हम लोगों ने सेंट्रल टेंडेंसी की बात कर ली, स्प्रेड की बात कर ली, हमने मीन मीडियन मोड निकाल लिया, हमने इंटर क्वार्टाइल रेंज निकाला। मैंने लास्ट क्लास में, हाँ, उसके अलावा कोरिलेशन निकाला, कॉजेशन निकाल लिया। सो दीज आर द पैरामीटर्स और दीज आर दी properties of your data set. Now after getting the properties of the data set, we tend to we would like to predict something. For that prediction we require the probability. ठीक है? So example के तौर पे जैसे यहाँ पर बोला गया है, rolling a dice, getting a 6. It is a possible outcome, but it is not 100% sure that you will get a 6 every time. Similarly, each possibility only has one outcome. So it is not like कि अगर मैंने कहा ये भी हो सकता है, ये भी हो सकता है, ये भी हो सकता है, तो एक ही टाइम पे तीनों चीज हो जाए. No, sorry. Only one outcome should be there. Thirdly, for example, the probability of getting a number 2 on a dice is 1/6. Is it true or false? It is
Yes,
true,
ma'am.
because we
Yes,
know
ma'am.
there are possible outcomes are 1, 2, 3, 4, 5 and 6. And हर किसी की आने की probability is 1/6. So it is true. So एक टाइम पर सिर्फ एक ही outcome आ सकता है. So prediction में भी क्या होगा? या तो ये होगा या नहीं होगा. हम ये नहीं कहेंगे कि शायद होगा या मे बी ये हो सकता है. नहीं. We'll simply say either it will fall it or it will not fall. So there are only two options. Out of these two options, both are having the equal probability, that is 0.5, 0.5. Now, किसके fall होने के chances होगी वो हमारे को analysis के बाद पता चलेगा. So again, there are certain terminologies with the probability. First one is the random experiment. Then there is a sample space, and then it is basically called as event. So we had studied about it. What is random experiment? An experiment or a process for which the outcome cannot be predicted with certainty. So,
Excuse me, ma'am.
yeah, beta.
Ma'am, can we please start the recording?
Oh, sorry. Please. Thank you. I'm really sorry. So, till this point, random experiment is basically an experiment or a process for which the outcome cannot be predicted with certainty. That means we are simply saying ki the chances of that particular event to occur, the chances of that particular event not to occur. So, it is not certain ki हाँ यही होगा. Then there is a sample space. The entire possible set of outcome of a random experiment is the sample space. So for example, chances of getting a 2 on a dice, it is not certain, but all the possible outcome 1, 2, 3, 4, 5, 6 are the sample space. Event. One or more outcome of an experiment is called event. Now that depends on what kind of event you are taking care of. If a subset of it is a subset of a sample space. So that means if I'll say chances of getting 2 in the next roll of dice is basically event. Sample space, all the possible outcomes are sample space. And doing rolling of a dice is basically a random experiment. Fine, class? Now, who will tell me what is this disjoint and non-disjoint event? मुझे आज तक ये clear नहीं हुआ. कोई बताना चाहेगा मुझे ये? What is this disjoint and non-disjoint event? Example भी लिखा हुआ है. Anyone, class?
मैम डिसजॉइंट इवेंट्स वो होते हैं जिन दो इवेंट्स में कोई कॉमन आउटकम ना हो.
Okay.
और नॉन डिसजॉइंट वो होते हैं जिसमें कॉमन आउटकम्स हों.
Okay. So right now, are we in a disjoint event or we are in non-disjoint event?
मैम मतलब कैसे?
एग्जाम्पल है तुम्हारे सामने, कोरिलेट करो. डेटा साइंस की क्लास चल रही है एंड ये इवेंट क्या डिसजॉइंट है या फिर नॉन डिसजॉइंट है?
हम दूसरा इवेंट भी चाहिए.
हाँ,
मैम वी नीड टू डिफरेंट इवेंट्स.
वी नीड टू डिफरेंट इवेंट्स. आई डोंट थिंक सो. किसी एक इवेंट पे ही काम कर सकते हैं हम लोग भी. हो रहा है वैसे. अभी अगर हम इस क्लास में बात करें डेटा साइंस की, तो देर आर नॉट इवन जस्ट 2, देर आर मोर देन 2 इवेंट साइमल्टेनियसली गोइंग ऑन. थिंक इन दैट डायरेक्शन. It says example, a single card drawn from a deck cannot be a king and a queen. एक ही कार्ड अगर मैंने ड्रॉ किया है तो ना जरूरी नहीं, आई मीन इट इज नॉट एट ऑल पॉसिबल कि वो किंग भी होगा क्वीन भी होगा. And example, another example, a student can get 100 marks in statistics and 100 marks in probability. Possible है या नहीं?
Yes, ma'am.
So disjoint and non-disjoint events are more focused. Now just tell me, हम अगर किसी भी डेटा सेट पर एनालाइज करते हैं तो क्या वो डिसजॉइंट इवेंट होता है या नॉन डिसजॉइंट इवेंट होता है, या क्या होना चाहिए?
मैम वैल्यूज पे डिपेंड करता है, अगर सारी वैल्यूज सेम हो तो वो नॉन
Exactly.
डिस्जॉइंट होगा.
It is totally dependent on the type of application we are working on. Now type of application doesn't mean कि मैंने एक मॉड्यूल बना रखा है. Type of application का मतलब ये हुआ मेरा डेटा सेट किस चीज को कोलेट कर रहा है. फॉर एग्जाम्पल अगर मेरा स्टॉक एक्सचेंज है तो ये पॉसिबिलिटी तो कभी भी नहीं आने वाली कि एक ही टाइम पर मुझे लॉस भी हो जाए और एक ही टाइम पे मुझे गेन भी हो जाए. हो सकता है क्या?
नहीं.
No, ma'am.
पॉसिबल है. अगर मैंने दो अलग अलग स्टॉक्स पे स्टॉक प्राइसिंग पे मैंने पैसा लगाया हुआ है तो हो सकता है एक लॉस हो जाए और एक गेन कर जाए. है या नहीं है? सो इट विल कम अंडर नॉन डिसजॉइंट इवेंट.
Non-disjoint.
गेटिंग माई पॉइंट? तो मेरे चांसेस ज्यादातर कहाँ काम करने के हैं? देख लो. इफ आई से जूही, she is good in maths and she is good in management, so fine, this is the thing. So if I'll actually start working on your class for mathematics as well as for management, what I'll have, major people I'll get कि हाँ दोनों subjects में दोनों सारे बच्चे major students are very good. Now I have the dependent variable dependency of the two data set, I know that. So यहाँ पर वही independent और dependent वाला फंडा लग जाएगा. जो कि मुझे नहीं चाहिए. सो आई हैव टू वर्क ऑन इट. फाइन क्लास. सो नॉन डिसजॉइंट इवेंट एंड डिसजॉइंट इवेंट occurs. It depends on type of application or type of data set we are having, on which we are working. Now the probability distribution. There is something called as probability density function जिसे हम कहते हैं PDF. And in fact ऐसे ना लिख करके बेटा PDF ना ऐसे लिखा जाता है, ठीक है, छोटे में. I'll tell you why. And there is one more, this is which is लिखते हैं हम लोग probability mass function which is called as PMF. Stats वालों ने पढ़ा होगा, पढ़ा है stats?
यस मैम.
Okay. So stats वाले मुझे बताएंगे what is this PDF and PMF. Not मुझे पूरी क्लास को बताएंगे what is this PDF and what is this PMF. So अभी के लिए सिर्फ इतना याद रख लो क्लास. There is something called as probability distribution. Probability distribution का मतलब ये है कि हमने जो भी हमारा एक्सपेरिमेंट हुआ हमने उसकी प्रोबेबिलिटी निकाल ली. उसके अंदर जो भी सैंपल स्पेस आया और सैंपल स्पेस के अकॉर्डिंग जो भी इवेंट अकर हुआ हमने उसकी प्रोबेबिलिटी निकाल ली. अब उसके बाद जब हम उसको प्लॉट करने की बात कर रहे हैं तो एक प्लॉट आता है, वो जो प्लॉट होता है उसे हम कहते हैं डिस्ट्रीब्यूशन. अभी के लिए सिर्फ ये समझ लो how it is being distributed for different number of experiments, that is basically called as probability distribution. Now in probability distribution we have two types of fundas right now. For the first case, that is probability density function and another one is the probability mass function. Okay, stats कौन बताएगा मुझे? हाँ जी, कौन बताएगा क्लास? बहुत आसान है. स्टैटिस्टिक्स में से कोई बताएगा या फिर मैं नाम लेना शुरू करूं? लेट्स गो फॉर स्टैट्स. बता दो यार, गलती होगा ना, कोई प्रॉब्लम नहीं है, मैं भी तो गलतियां कर जाती हूँ. ओके, स्टैटिस्टिक्स. नंदनी, आर यू देयर बेटा?
Yes, ma'am.
Okay, can you tell beta? Let it be the wrong one, not a problem.
Ma'am, probability density function is a function of a continuous random variable.
So,
and for
then?
And for probability mass function, it's a function for a discrete random variable.
Okay, what exactly information they are providing? क्या निकाल के देते हैं?
Probability.
Anything else?
Ma'am, for a particular value of x, there is a px in a defined interval. For continuous case, we perform integration and plot integrate each and every value just because it's a continuous function. And for discrete cases, we add in a cumulative way.
Okay, fine. So class, let's talk about PMF and PDF. तो पहली चीज बात करते हैं. We all know there is a random variable class. We know that. What is random variable? हाँ या ना तो बोलो फर्स्ट ईयर. रैंडम वेरिएबल हमने पढ़ा है. सो रैंडम वेरिएबल कैन बी एनीथिंग. फॉर मी रैंडम, हम हमारी सबसे गंदी हैबिट क्या है, हम ना 3 वेरिएबल से सबसे ज्यादा काम करते हैं, एक्स वाई एंड जी. ठीक है. एंड प्रोबेबिलिटी हो, स्टैट्स हो, तुम कुछ भी उठा के देख लो तो तुम्हारे को सारे नोमेनक्लेचर इन्हीं टर्म्स में मिलेंगे. सो फॉर अस रैंडम वेरिएबल इज बीइंग डिफाइंड बाय कैपिटल एक्स. And this x is nothing but any kind of event that has to occur, right? So now this random variable is further being divided into two types of variables. It can be in continuous nature and it can be a discrete one. Who will tell me what is continuous and what is discrete? So continuous is anything between 0 to infinity. Can I say that, or it should be minus infinity to plus infinity? Can I say that?
Minus infinity to plus
Minus
infinity.
to plus.
So it is from minus infinity to plus infinity. That means all the float numbers. Floating का मतलब पता है ना सबको क्या होता है? All the real value numbers. It can be fraction, it can be constant. But for the discrete case, हाँ जी class, discrete के लिए क्या हो जाएगा?
Specific numbers 1, 2, 3.
Specific numbers. So I'll simply say all the integers. So it can't be 1.5. I will not take 1.5 as discrete. I'll take 1 or 2. I can't take in between fractions. So these are the basically the integers. जो और हम सबको पता है 1.5 is not an integer, 2.8 is not an integer, 30.45 is not at all an integer. So my integers are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, in continuous also they are treated as this, but in continuous we will never write 1 as 1. It will be written as 1.0. So there is a difference between this and this. This is discrete, this is continuous. समझ रहे हो क्लास? तुम ये अपने पाइथन में भी चेक करके देख लेना. तुम्हें डिस्क्रीट हमेशा ऐसा दिखेगा और तुम्हारे को पाइथन में डिस्क्रीट कंटिन्यूअस ऐसा दिखेगा. या so this is the biggest difference. So basically what we are going for, we are actually defining our random variables in these two terms, that is continuous random variable and discrete random variable. Broadly speaking, I'll redefine it. Continuous random variable is continuous. Discrete random variable is basically for the, we can say that it is being categorical. Categorical matlab we are defining it for specific values. That means 1, 2, 3, 4. Now they are categorized. So for categorical, we are going for the discrete thing. For continuous, it is totally continuous from minus infinity to infinity, all the real values. So this is always in a number data set. So for this, there is a probability distribution that is being defined by PDF and PMF. Now PDF is related to your continuous random function and PMF is related to your discrete random function. दोनों एक तरीके से काम करते हैं. जैसे continuous function काम कर रहा है वैसे ही discrete function काम कर रहा है. The only difference between these two is for continuous, whenever we are going to calculate the PDF, it has to be integral of that. ठीक है? And for probability mass function, whenever we are calculating it for discrete, then it has to be sum of all the observations. So it will be the sum of all the probability of the observations. So over PDF, it is integral. Over PMF, it is summation. Is it okay, class?
Yes, ma'am.
So it is simple. The probability density function is concerned with the relative likelihood. तो बहुत बार ये वर्ड तुम्हें सुनने को मिलेगा, relative likelihood for a continuous random variable to take on a given value. The PDF gives the probability of a variable that lies between the range A and B. Now A is minus infinity, B is plus infinity. So this is something like we are getting. It is a bell-shaped graph. ये वाला. It is a bell-shaped graph, and because it is continuous in nature, तो तुम देख लो, there is no discontinuity in the graph. It is starting from -4 to +4, where A is almost -1 or sorry -2 and -1 के बीच में है. Similarly, B is in between 1 and 2. So automatically we are having a plot. This is basically called as a PDF. And similarly, if I want to plot for my PMF, so definitely PMF will also look like this. So we are actually more concerned about PDF because major data set is in the continuous form, but that doesn't mean कि we don't calculate PMF. We definitely calculate PMF for the case of discrete variables. जहाँ पर भी मेरा कैटेगोरिकल डेटा आ जाता है वहां पर हम लोग पीडीएफ पे काम नहीं करते, पीएमएफ पे काम करते हैं. या फिर वी हैव टू अप्लाई सर्टेन टेक्निक जिसे हम असेंबलर्स बोल देते हैं. उन पर काम करना पड़ेगा so that they can convert our categorical data into a continuous data. So now what PDF holds, there are three properties of PDF. The graph of the PDF will be continuous over a range, जो कि मैंने बोला there is no discontinuity. The area bounded by the curve of the density function and the axis is equal to 1. Area bounded by the curve. So if I'll talk about this, के अंदर का जितना भी area, if I'll integrate it from a minus a to plus a plus b, so I'll have the final value as 1. इसका मतलब क्या हुआ? Integral of some function. हम इस तरह से लिखते हैं class. This is not there. This is basically called as PDF from let it be some ranges, then it is equal to 1. This is actually the PDF. And PMF हमारा क्या हो जाता है? PMF भी यही चीज होता है, लेकिन it is now in summation. So I'll say n is equal to a से लेकर के minus a से लेकर b तक, and I'll write in terms of capital X, then it is equal and it has to be equal to 1. Then it is called as PMF. Just understand continuous smaller cases and discrete in capital cases. The probability that a random variable assumes a value between a and b is equal to the area under the PDF bounded by a and b. So that is the basically the probability. So basically हमने करा क्या है यहाँ पर? हमने यहाँ पर इस range पर जो भी plot किया, that is basically the probability. That is basically the event that we are counting, and there it is basically the probability. So if I talk about the probability, so area under this basically gives you the probability of that particular event to occur. Now, ये जो बेल शेप ग्राफ बनकर आता है ना बेटा, ये बहुत ही इंपॉर्टेंट है. सो देयर इज अनदर काइंड ऑफ डिस्ट्रीब्यूशन एंड दिस इज द ओनली डिस्ट्रीब्यूशन दैट हैज टू बी फॉलोड. सो इफ आई से व्हाट काइंड ऑफ डिस्ट्रीब्यूशन वी हैव टू फॉलो, इट हैज टू बी द नॉर्मल डिस्ट्रीब्यूशन फॉर एनी काइंड ऑफ ग्राफ, बिकॉज यही एक ग्राफ है जो एक्चुअल में स्टैट्स के साथ हमें सबसे ज्यादा इंफॉर्मेशन पास ऑन करता है. So normal distribution, otherwise also known as Gaussian distribution. This is another name for the normal distribution. And ज्यादातर market value की अगर बात करी जाए, तो this word is being used, and it is being called as a normal distribution. We don't say कि Gaussian distribution is a different kind of distribution. It is as good as normal distribution. So it is normal distribution. Is a probability distribution that denotes the symmetric property of the mean. Symmetric property of the mean का मतलब क्या हुआ? Central point will be counted as mean. So between these two extreme points, if I'll see move towards this side or this side, they will be having the same values. So basically they are mirror image at mean. The idea behind this function is that the data near the mean occurs more frequently than the data away from the mean. It infers that the data around the mean represents the entire data set, जो कि logical है. Because we are simply saying, I'll simply say till this region I will be working. Till this region. So it is simple. It simply says that if I want to take this region, so this region is actually defining my data set because it is more closer to mean. That means majorly the frequency of that particular events और जो भी हमने experiment hold किया है, उसके chances इस particular peak के आसपास बहुत ज़्यादा है, तो यहाँ पर analysis करना बहुत better रहेगा rather than working at this region or at this point. So this is basically given by the normal distribution, and this is actually being followed in the data set. तो तुम लोगों ने, आई होप, मैंने जब अपना शीट शेयर किया था, आई शोड यू दैट ग्राफ जहां मैंने तुम्हें बोला था दैट इट इज राइट स्क्यूड. तो वो किसके साथ कंपेयर किया? मैंने अपने नॉर्मल डिस्ट्रीब्यूशन के साथ कंपेयर किया है, बिकॉज आई नो नॉर्मल डिस्ट्रीब्यूशन का मतलब क्या होता है. ये जो डायग्राम मुझे दिख रहा है, एंड उसके ऊपर मैंने अपने वाले डायग्राम को विजुअलाइज किया, सो इट वाज कमिंग लाइक दिस. and I am getting the point that it is right skewed. So I know this. So what we have to go for? Normal distribution. It is also called as Gaussian distribution. इसका main purpose क्या है? It is kind of a distribution that is symmetrical around the mean of the data set. That means कि at the mean they are symmetric. Both the sides they are symmetric, and or I can say that the data near the mean is much more frequently occurring rather than they are far off. तो मिलता क्या क्या है अब हमारे को नॉर्मल डिस्ट्रीब्यूशन से वी गेट अ मीन and the standard deviation. So you'll get to know over here अगर axis देखोगे तो it is basically mu, यहाँ पर standard deviation is mu and your standard deviation is equal to 0 at mean. Then next point is basically mean and the standard deviation. First standard deviation, second standard deviation, third standard deviation. ऐसे यहाँ पर है. So ये axis can be stretched out. So now the mean defines the location at the center of the graph and standard deviation determines the height of the graph. So क्योंकि यहाँ पर sigma is 0, so mean itself is the height. Over here it is only the sigma, it is twice of sigma, it is minus thrice of sigma. So mean आपका बताता है कि what is the central point of the peak and standard deviation height of the graph. If the standard deviation is small, the curve is tall and narrow. क्योंकि हमें दिख रहा है अगर sigma is equal to 0 हो रहा है, sigma is equal to some smaller value 0 point something or that. If sigma is very high, then the height is very small. Is it okay till this point, class?
Yes, ma'am.
Okay. Who will tell me what is the central limit theorem? I don't know what is the central limit theorem. Read it and please let me know what is the central limit theorem. और ये ना तुम बना के भी देख सकते हो, जो ये कह रहा है ना वो तुम बना के भी देख सकते हो.
मैम एक हमारा सैंपल स्पेस होगा, उसके हम ना सबसेट्स बनाएंगे, फिर उन सारे सबसेट्स का जो मीन निकालेंगे वो इक्वल होगा हमारे फर्स्ट सैंपल स्पेस के मीन के.
Then
यही है सैंपल.
okay. So I can simply say that no matter what, if I have a independent random variable and if I'll plot it, okay, if I'll plot the sampling distribution of that independent random variable, then I'll get all the variables. मतलब अगर मेरे पास suppose 5 variables है and they are independent by nature, and if I'll go for their sampling distribution, it will follow the same kind of distribution जो मुझे normal distribution पे मिला है. और सारे variable, not just one, all. So if I'll go for sampling at n equal to 50, if I'll go for sampling at n equal to 10, if I'll go for 3, if I'll go for 1, the peak value, the central limit theorem simply says that the mean value will remain the same. तो अभी किसने आंसर किया था क्लास? Who answered this question right now? Central limit theorem अभी किसने समझाया था? So basically what we are doing, अगर हमारे पास कोई भी sample space है, उस sample space को अगर हम sampling करते हैं या grouping करते हैं with different kind of groups, then the mean will be coming out to be the same. So that is whatever over here it is being done. Capital N is basically telling you what is the sampling rate. So over here there was some experiment conducted and उसका जो sample space था उसको n equal to 50. That means एक group के अंदर हम लोगों ने number of samples जो रखे that is 50 and accordingly we measured out, so we get a peak value. Then again for 10 we get a peak value. Then again for 3 we got a peak value. So the mean value is coming out to be same at the same position. Fine. So that is basically called as the central limit theorem. ठीक है, and it is very much possible. अगर ये small data set होगा तो definitely it will be a false case. If I'll go only for something that is having an observation or the sample space of 10 data point, it will give you a false statement. It will be totally a Simpson box. Why? Simpson paradox. Why? Because central limit theorem will be contradicting. But अगर मेरे पास sample size बहुत बड़ा है, then only it will work out. So that means having a data set of almost 10 rows will not suffice. Having a data set of more than thousands or lakhs or millions, it will definitely give you, it will follow the central limit theorem. That's the only reason that we follow actually central limit theorem for the normal distribution. इसीलिए normal distribution along with central limit theorem actually gives us the information. जो मैंने कल की क्लास में तुम्हें दिखाया था कि देखो यहाँ पर जो मेरा 50% मीन है वो एक्चुअल मीन के साथ कितना मैच कर रहा है. आई होप सबको याद होगा.
Yes, ma'am.
So
Yes,
that is exactly why we require the central limit theorem. Now the accuracy, this is the important word for machine learning. The accuracy or resemblance to the normal distribution depends on two main factors. First one, number of sample point taken, and the shape of the underlying population. So मुझे my back of mind is having this distribution. मुझे बहुत clarity से पता है कि normal distribution has to be symmetrical in nature. After this, if I know actually in what amount of sampling I had done, then the shape of this particular population should be as same as the normal distribution. If it is following the same normal distribution curve जो हमारे को पता है होना चाहिए, अगर वैसा ही कुछ आ रहा है, then it is the accuracy is very high. But if it is not following, जैसे कि कल की क्लास में था, I was getting a response like this. So I know it is not following the normal distribution. So I am looking into it ki fine, why it is not following the distribution? Because there is more of spread. There are more values in the data set that are not closer to the mean value. That means that are not frequently coming out. So I got the information. Now this kind of information I have to fetch. I just don't want to look at the shape of the graph only. But अगर मैं as a statistician, अगर मैं सिर्फ concept की बात करूँ तो yes, I have to resemble my final output with the normal distribution and how closer that normal distribution with the output is resembling. अगर वो perfectly resemble कर रहा है, accuracy is very high. अगर वो नहीं कर रहा है, then there are chances that the data points are actually varying a very far off with the mean value. Why? Because they are not occurring frequently in the data set. If they are not occurring frequently in the data set, that means the spread is more. Randomness is very large. That means data set is not well structured. There are certain losses into it. So we have to take care of that. तो यहाँ से हमें ये information मिलती है. Now the types of probability, class, I'll work till conditional probability today. After this Bayes theorem, I will not start today. So marginal probability कौन बताएगा मुझे? Please read it and let me know what is this marginal probability. The
probability of an occurring irrespective of any other event.
Okay, it is the probability of an event occurring unconditioned on any other event. For example, the probability that a card drawn is a 3. So it is 1 by 13. Why 1 by 13? Because we all know that there are 4 different set, and for every different set it is total number of cards are 52. So if I'll go for that, there are 4 different sets. So 4 divided by 52. Is it okay? Any other example?
Yes.
Any other example for this kind of marginal probability? Okay, one more thing. Is it a discrete or a continuous marginal probability? It is discrete. Just see over here. It is summation. Just understand. Whenever there is a summation, always understand this is discrete. That means it is not asking for something like this. It is not asking for this. It is actually saying that if n is equal to 4, what is the probability? Then joint probability. कौन बताएगा? Read it.
Ma'am, it is the measure of two events happening simultaneously.
Okay, then it is
For
basically called.
every x and y, there is the value of fxy.
Okay, for every value of x and y, there is a value of x and y. Okay.
fxy.
Okay. So the joint probability is a measure of two events happening at the same time. You are attending the class simultaneously. You are active on your WhatsApp. Now this is basically the joint probability. What is the chances that you are while attending your class, you are active on the WhatsApp? So first event is class is going on. Second event is all active active on WhatsApp. So now these are having two independent probabilities as well as the joint probability because they are occurring at the same time. Okay, so now over here, this is very much important, the same time. So now the probability of event A and probability of event B are occurring, that we are aware of. PA and PB are aware, we are aware of. If the probability of the intersection of two or more events, it is the probability of the intersection of A and B can be written as PA intersection B. So can I say that PA union B is equal to P of A plus P of B minus P of A intersection B? Can I say that?
Yes,
Yes,
ma'am.
ma'am.
तो ये फंडा हमने ऑलरेडी पढ़ा हुआ है बिकॉज शायद यही प्रोबेबिलिटी का कंसेप्ट हम पढ़ करके आए हैं एंड यही पूरी प्रोबेबिलिटी है. सिर्फ और सिर्फ निकालने के तरीके अलग हो गए. जैसे हमने बोल दिया जॉइंट प्रोबेबिलिटी क्या है, मार्जिनल प्रोबेबिलिटी क्या है, कंडीशनल प्रोबेबिलिटी क्या है, एंड देयर आर एन नंबर ऑफ अदर काइंड्स ऑफ प्रोबेबिलिटी. तो एक्चुअल फंडा इज दिस ओनली. व्हाट इज यूनियन एंड व्हाट इज इंटरसेक्शन एंड व्हाट आर द इंडिपेंडेंट प्रोबेबिलिटीज. एक्चुअल फंडा यही है, बस इसको रीफ्रेम कर दिया गया है हर बार. ठीक है. So now it simply says that we can calculate the joint probability, which is basically PA intersection B. Now, last one for us. Why marginal, joint, and why conditional probability is much more important for our data science?
Ma'am,
Let's
it's
talk
helpful
about-
in Bayes theorem.
It helpful in Bayes theorem. मुझे Bayes theorem ही नहीं पता. तो conditional probability की क्यों जरूरत है? Why not joint probability? So let's talk about it. What is conditional probability?
Ma'am, it's like the probability that an event is going to happen given that another event has already happened.
दैट मीन्स एक इवेंट का होना जरूरी है. मतलब अगर पहला इवेंट नहीं होगा तब तक दूसरा इवेंट नहीं अकर हो सकता.
Yes, ma'am.
फाइन. सो the condition has it is basically giving you a condition. So condition has to be followed first, then the event has to be taken care of. So if I'll say that PB/A is given, so this is my PB/A, which simply says that probability of event B occurring given that event A occurred. That means जब तक मेरा इवेंट A अकर नहीं होगा ना तब तक प्रोबेबिलिटी ऑफ B नहीं निकाल सकती मैं. तब तक मेरा B इवेंट अकर नहीं हो सकता. So I have to follow the condition. So probability of an event or outcome based on the occurrence of previous event or outcome. Conditional probability of an event B is the probability that the event will occur given that event A has already occurred. This is very much important. And this is actually the base of Bayes theorem. Until unless conditional probability valid नहीं है, Bayes theorem पे कोई काम करने का मतलब ही नहीं बनता. So अब तक हम क्या काम करते थे? हम सिर्फ ये बोलते थे probability of event A is this, probability of event B is this, and probability of event both the events are occurring, then it has to be something else. Fine. Now what it is saying? Now it is saying कि आपका A और B दोनों independent. Now you have to say कि अगर आपका B event होना है तो पहले A के event occur होने के chances क्या है? So we should go for that. So हमारे लिए ये conditional probability निकालना बहुत जरूरी है. Now who will tell me why this is more important for data science?
Ma'am, because in data science we have to carry out predictions. So if we are knowing the prior things, then it becomes easy.
Okay, and I think prediction हम उसी के लिए करते हैं जब हमारे को past history पता हो, then we can tell
Yes,
exactly
ma'am.
predict क्या हो सकता है. That's the only reason we require the conditional probability. Getting my point, class? So now the second thing it says if A and B are dependent events, then the expression of conditional probability is given as PB/A, which is equal to PA union B divided by PA. So class, this is basically written as PB by A is equal to PA union B by PA. अगर ये दोनों के दोनों डिपेंडेंट वेरिएबल है. एंड आई होप तुमको पता, कल मैंने क्लास में बहुत क्लैरिटी से बता दिया था, अगर मेरे दो फीचर्स आर डिपेंडेंट ऑन ईच अदर तो दोनों को साथ में लेके चलने से मेरा एनालिसिस हेल्पफुल नहीं होने वाला. सो व्हाट आई विल डू, आई विल सिंपली ड्रॉप वन एंड आई विल टेक वन. यही बोला था मैंने क्लास में. सो इफ दे बोथ आर इंडिपेंडेंट, दैट मीन्स अगर ए और बी दोनों एक दूसरे पे डिपेंडेंट है, सो आई कैन सिंपली गो फॉर ए for the calculation of B. तो A की जगह पे मैं B को यूज कर सकती हूँ और B की जगह पे मैं A को यूज कर सकती हूँ, provided they both has to be dependent on each other. But if they both are independent events, then what is happening? Then the expression for conditional probability is given as PB/A is equal to PB or it is equal to PA. Slight homework. बहुत छोटा सा है. हाँ बेटा.
मैम ऊपर इंटरसेक्शन आएगा ना, P इंटरसेक्शन है.
मैं I was just waiting for this कि कोई तो बोले. Right? This is PA intersection B by PA. What I want you people to do is, यहाँ तक समझ में आ गया ना कि इंडिपेंडेंट और डिपेंडेंट का मतलब क्या होता है? ठीक है. इंडिपेंडेंट के लिए द फॉर्मूला conditional probability turns out to be the probability of a event itself. But for the case when they are dependent, then it is being coming out to be PA intersection B divided by PA. Now what I want from you people is, kindly prove this identity. I have this only. I want you people to come on Wednesday fully prepared with this. That either it will be coming out to be this or it will be coming out to be this. दोनों में से दोनों ही आएंगे, but मुझे सिर्फ ये चाहिए कि आ कैसे रहा है. I want you people to prove it.
Yes, ma'am.
ठीक है? So kindly do it.
Okay.
Fine. After this we'll be going. So conditional probability till this point it is clear to everyone what is conditional probability. If it is an independent event तो क्या है और अगर वो dependent event के साथ है तो क्या है. That's it. Now what you people have to come up with, you have to prove this identity, and lastly we'll be going for the Bayes theorem. What exactly the Bayes theorem is. So conditional probability बस याद रख कर आना और finally identity prove करके आनी है. Fine class? So I am not going for this Bayes theorem right now, and ये point estimators और ये सब additional है. You people can read it. Confidence interval, yes, I'll tell you what exactly it is because it is actually required for your data science. Okay, so let me take your attendance now. Okay. Juhi,
Present, ma'am.
Sachi,
Present, ma'am.
Shalini,